Okay, we're back with one more example involving implicit differentiation. The key thing here for this problem is we realize that all derivative rules apply. So product rule is fair game, quotient rule is fair game, chain rule is fair game. You can see above my shoulder we have a situation where we're going to be doing the chain rule. Okay, so we have, actually we'll be doing the product rule as well. We have x times y, that'll be a product rule, plus sine y, that'll be a chain rule. Okay, even though it's implicitly defined curve, it's okay. We can still do all the rules that we've learned already. So let's go ahead and do that. Product rule, the first term is x, the second term is y. Derivative of the first, okay, derivative of x is 1, don't need to write that. Then we keep the y. All right, derivative of the first times the second, plus, now we keep the first term, we keep the x, and we take the derivative of the second term. The derivative of y is also 1, but it gets a dy dx. I'm not going to write the 1, but there is technically a 1 right there. And then dy dx. Okay, so there's our product rule to derive that xy term right there. Okay, just like we did the product rule in the previous example. Okay. Then we have our plus sign, and then we see sine of y. Okay, well if that was sine of x, what would be the derivative of sine x? Good, it said cosine x. Hopefully we have our trig derivatives memorized by now. So sine x would go to cosine x if we took the derivative, therefore sine y will go to cosine y. Okay, but we know that if it's not x, it's ugly. It means there's a chain rule involved here. We're taking the derivative of y, that's our inner function, and the derivative of y is dy dx. So we have a dy dx right there because we're deriving a y term. Just like over here, when we derive this y, we have dy dx as well. Okay? That's going to be equal to 0 because the derivative of 4 is 0. And now we're just doing everything we've done before. We got to get the dy dx term all by itself. So we've got to isolate the dy dx term. Well, this term has a dy dx. This term has a dy dx. This one does not. So we got to start by getting it over to the other side. Piece of cake. And that gives us x dy dx plus cosine y dy dx is equal to the opposite of y. Just like before, multiple dy dx terms, so we factor the dy dx out. We're left with x from the first term. We're left with cosine y from the second term. Okay. And that's still equal to the opposite of y. We want to get dy dx by itself, so we'll divide by the other expression. So we're going to divide by x plus cosine y, do that to both sides, and we are done. Okay, dy dx is left over on the left, and the opposite of y over x plus cosine y is left on the right. That is our derivative. Okay. So hopefully these examples will help you fill out that worksheet, and we'll be back soon with starting to put this into use. Equations of tangent lines and approximations. That'll be coming up in the next set of videos.